Hi everyone, this is Ravinder Paskula. In this video, we are going to discuss about TensorFlow computational operations. Now, I'll tell you clearly what are different operations we can perform in TensorFlow. We'll discuss one by one. Yes. So TensorFlow brings all the tools for us to get set up with the numerical calculations and adding such calculations to our graph. That means while creating a computational graph, we'll add different methods to it. TensorFlow has a list of methods for implementing calculations on tensors. There are different built-in methods are there for addition, multiplication, division, square root, seal, etc. etc. For each and every operations, there are plenty of methods, built-in methods are available in TensorFlow framework. Each method is represented by a function of the TF package. Okay, by using TF package, we can use that built-in methods. And each function returns a tensor. That means that function uses tensors, do some operations and give the result. Now, for example, this one and right side are two tensors. It carries the data to give the operation a node. So this node can perform different operations. Okay. Now we can create a tensor with the empty tensor by using placeholder, or changeable tensor by using variable, by unchangeable tensor by using constant. So like we can create a tensor with a different way. Now we'll see what are different mathematical operations are available. We'll discuss. Now here, for example, we perform arithmetic operations like addition. Right? Addition we can perform. We can perform subtraction, we can perform multiplication, division, modulo operations, seal, square root, multiplication, etc. etc. We will do a number of mathematical operations. For example, here, now the first one, for example, addition. Assume that this node can, the node in computational graph represent operation. Now this operation requires n number of tensors. Now, for example, here in this diagram, it takes one tensor and right side another tensor. That means it takes the data through two tensors and it will calculate some operations based on method and it produces resultant tensor. And another one, multiplication and subtraction, etc. etc. All this computational graph we have to define it, design it. Then later we have to run or execute all these methods. Okay, now we'll discuss in practical way how to implement all these things. Yeah, TensorFlow operations. Yes, we can perform addition, subtraction, multiplication, division, modulo division, etc. by using two tensors, right? Yeah. Now first addition operation with a TensorFlow. Okay. Yeah, first of all, we have to import TensorFlow compatible with the version 1 as TF. By using TF, we have to disable and enable, we have to use version 2 behavior. Yes. Now we can use the TensorFlow easily. Now first we have to create tensors, right? So already we are seeing that graph. So this graph we have to create it. So with the two tensors, we have to create two tensors and one node, that means operation, and it will produce one resultant tensor. Yeah. Now I want to create A is equal to, by using TF package, we can create, for example, constant. The constant requires with some initial value here. I am giving 3, and another one is equal to TF dot constant 5. Okay. Now we created this one. And another one, the resultant tensor, we have to create it, right? Yeah. So as per this diagram, so two tensors we created with the constant method. Now it will produce the resultant tensor. So that is what C. Now C is equal to TF dot at A comma B. Yes. So this add represent node in the computational graph. This add represent node in the computational graph. It will do the addition operation on two tensors. Now in this, this operation. So it will perform addition operation with the help of two tensors, and it produce tensor C. So this is tensor A, tensor B, and after doing some addition operation on these two tensors, it will produce the resultant tensor, that is C. Yeah. So till here we defined a computational graph. Yeah. Defined a computational graph. Yes. Now we have to execute. The computational graph. Yes. How we can execute a computational graph? By using run method. Okay. So we have to create session, right? Yeah. Session by using session class. Yes. Now object says package, TF package is there. By using TF package of session class, yes, we have created now object. We have created session. Now after creating session, by using run method, the total graph will be implemented. Now I'll see how to implement it. Yes. Three 5 is equal to 8. Clear? Yes. So this graph here we added here value how much 3 I given here, and here I given here I given 5. Yes. So this tensor B, how much value? 5 I given. This one tensor A, how much value? 3. Now whatever this one, the resultant tensor should be 8. Yes, A plus B. Yes, here it will perform A plus B right. Now the resultant yes, this one is the resultant tensor. Resultant tensor, how much here? Its name is C is equal to how much? 3 plus 5, 8. So like we can develop, we can implement, we can develop and implement a computational graph. Now coming to the another operation. Now here we have given only scalar values. So scalar means what? Single value, right? Because you know its rank is 0. Rank is 0, value is 1. Only one value is there. If rank is 0 and value is 1, that is what scalar. If rank is 1, that is what vector. Rank 1 with a single dimension. Shape 1. Shape is 1. Okay. And rank is 1. It's a vector. If rank is more than 1, so it's called as what? Array with multiple dimensions. Now we'll see that different dimensions. Here I'm giving here just created a tensor with a its shape is 1, 3. That means 1 row and 3 columns. And second tensor here I am creating here, yes, 1 row, 3 columns. Okay. Now we can add these two tensors. We can add these two tensors by using add method. Session, we have to create a session. Yes. Session object we created here. Then we have to run the A tensor. Now by using add method, we can add these two tensors, A underscore tensor and B underscore tensor. So once you add these two, we'll get result. First I displayed tensor A underscore tensor here and another one B underscore tensor. Now if you add these two, 1 plus 2 is 3 and 3 plus 3 is 6 and 4 plus 4 is 8. Like we can do operations on matrices. And coming to the multiple tensor. Okay. Okay, before going for adding multiple tensors, let me explain about subtraction operation. Yeah, we can perform subtraction operations on created two tensors, A and B. Yeah, simply we have to use subtract method. So this subtract method, it can subtract just single scalar values or arrays. Okay, now we'll get result. -1, -1, 0, 0. Same thing, if you perform multiplication operation, so we can do that operation by using multiply method. By using multiply method, we can multiply two tensors. The tensors, already I told to create the tensors, we can create tensors by using constant method, by using placeholder, by using variable. Okay, yes, the result is will be stored in mul variable, and by using multiply method, we can multiply these two. Now if you can see its output on the screen, just yeah, we got 15. 5 into 3, we have given values 5 into 3, 15. Here I have given values 3 into 3 and 5. So 3 into 5, 15. So if you give that A underscore tensor and B underscore tensor, it will do different one. Yes. Multiply, I am using, instead of giving square values, I am giving multiple values. A underscore tensor and B underscore tensor. Now we are adding two matrices. 1 by 3, 1 by 3, 1 by 3 matrices we are multiplying. So once you multiply these two matrices, we'll see this one. Yes. We got some error here. We'll rectify it. A underscore tensor is not defined. Maybe spelling mistake is there. We'll see. A underscore tensor here we have created. Okay. B underscore tensor. Once we multiply it, we have to get multiplication operation. We are not performing here. Name A tensor is not defined. Okay, no problem. We'll create it here. Yes. Import TensorFlow compat as tf disable underscore version 2 underscore behavior. Yes. Now A underscore tensor is equal to tf dot constant. Okay. 1 comma 2 comma 3 I am giving here. Yes. Now I'll create a session multiplication operation, right? Yeah. C is equal to C underscore tensor. Tensor is equal to tf dot multiply A underscore tensor comma B underscore tensor. Okay. Till now we created, we defined a computational graph. Now we have to create session tf dot session. Yes. Now if n see its value, we have to run it. C underscore tensor. Import spelling we did here. Yeah. Yes. Done. Yes. 1, 4, 9. So now we can multiply, tensor with multiple values. Now coming to the division operation. If you want to perform division operation, we'll get it. So like this. If you do that operation on arrays, we'll get output like this by using divide. So this is what the divide. It will give the quotient. Now if you want to modulo division operation, we will use div. The div indicates what? It will give the modulo division operation. We'll get output like this. We won't get quotient values, we'll get remainders. Now what if you want to perform multiple mathematical operations on multiple tensors? Now if you want to add, if you want to multiply, if you want to divide or any operation on multiple tensors, then we'll use add underscore and method. By using that, we can do addition operations or any other operation. Yeah. So this function add underscore n function used to add multiple tensors. So previously, so we have done mathematical operations, addition, subtraction, multiplication, division on two tensors. Now what if you want to act on multiple tensors? So for that purpose, we have to use this add underscore n. Yes. Now here I have defined three tensors, T1, T2 and T3. Right. So all are contains what? 1:3. 1/3. Now here 3/3. So this is what? 3/3 matrix. Now T2 also 3/3 matrix and T3 also 3/3 matrix. Now I want to perform addition operation on 3/3 matrices of 3 matrices. 3 matrices with a 3/3 dimension. Now, so after that, just add multiple tensors by using add underscore. Previously, to add two tensors, we used the add method. Now we are using add underscore n. So that add underscore n will add multiple tensors. Okay. Now here we have to create a session because we are executing the computational graph. Till here, just we designed the computational graph. Already we have seen that graph, how to design it. Okay. Now we have to run it. We have to execute it. Now if you have to execute it, we have to create session, and after the session, then we are by using run method we can execute this graph. Yeah, session has created. Now we have to run the computational graph by using run method. Run. That result will be stored in add underscore multiple underscore tensor. Now we'll see the result on the screen. Yes. So like we can add 3 matrices. Add 3 matrices by using add. Okay. Now I'll conclude the session. In the next video, we'll discuss about the remaining mathematical operations like find the square root of the matrix, find the square root of the single scalar value or array with multiple dimensions. The same thing we can do square root function, round values, etc. So we'll discuss in next video. Till then, bye bye. Take care.
Like, share and subscribe. Hit the bell icon for more updates.